Hello students, myself Dr. Divya, Assistant Professor at Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will discuss the question bank tutorial on electrochemistry and corrosion. So here we have problem solving and critical thinking questions. So the first one is, why lithium is best reducing agent whereas fluorine is best oxidizing agent? So if you see this question, lithium in the electrochemical series, lithium is present in the lower state and fluorine is having higher reduction potential. So therefore it is having high reduction potential. So the capability of reducing is high for this fluorine. So therefore it becomes oxidizing agent. So that is why lithium is best reducing agent and fluorine is best oxidizing agent. So according to this electrochemical series, lithium has the lowest reduction potential, which means it acts as best reducing agent. Lowest reduction potential, best reducing agent. And fluorine has the highest reduction potential, so therefore acts as oxidizing agent. So this is how we have to remember the reduction potentials. The positive is very high compared to the negative potential, so therefore the lowest reduction potential is best reducing agent. Next one, what is the composition of salt bridge used between two half cells? Why is salt bridge used in construction of cell? So if you see, this is galvanic cell, for example, galvanic cell. So we have copper sulfate and zinc sulfate here. So copper sulfate and zinc sulfate. So here, sorry, this is zinc sulfate and this is copper. Zinc sulfate and copper sulfate. So here the zinc is highly reactive and it becomes Zn2 plus ions and 2 electrons. So these 2 electrons are taken up by the copper 2 plus ions and forms copper, the deposits. Now here zinc is highly reactive, so it is forming the zinc 2 plus ions. So more and more zinc is coming out of this zinc rod, and more sulfate ions are building up here around the copper rod. So this will create new imbalance in the solutions. Imbalance in the solutions are the electrolytes. So to avoid this imbalance, whenever there is an imbalance in the ionic state, so the cell will stop working because no further zinc ions will come out, because already zinc ions are present that will build up around this rod and therefore it will avoid. So for that we are using a salt bridge that contains KNO3 or KCl. So why only KNO3 or KCl or NaCl? So these have similar transport numbers, because these have similar transport numbers. The anion and the cation must have similar or nearly equal transport number, only then they are used in the salt bridge. So these salts are dissolved in agar-agar and then kept in this U-tube, bend tube, and used as salt bridge. So this salt bridge will neutralize the solution, like these excess ions are compensated by the negative ions, and the excess ions here negative the anions are compensated by the cations. So this is how the salt bridge is used in balancing the electroneutrality. So the salt bridge is a vital component of any voltaic cell. So it is a tube filled with an electrolyte solution, KNO3 or KCl, and the purpose of salt bridge is to keep the solutions electrically neutral and allow the free flow of ions from one cell to another cell. Only when there is a flow of ions or electrons from one cell to another cell, the electricity will be generated and the cell keeps working. So therefore salt bridge is very important. So without salt bridge, what happens? The positive ions and the negative charges will build up around the electrodes and stops the reaction, stops. So that is why salt bridge is very important and it must be used whenever the voltaic cell is present. Next, what are the electrodes and electrolytes used in lead acid battery and lithium ion battery? So if you see lead acid battery, so the name itself indicates lead is used and acid is used. So anode anode like lead plate is used, and cathode lead dioxide plate is used. And the electrolyte here is sulfuric acid. Similarly, for the lithium ion battery, the name indicates that only lithium is used. So here anode is graphite with 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 intercalated lithium. It means the graphene layers are intercalated. In between the graphene layers, there will be lithium intercalated. And the cathode will be lithium compounds like lithium cobalt oxide or any other compound. And the electrolyte is lithium salt dissolved in organic solvent. So these are the electrodes and electrolytes used in lead acid battery and lithium ion battery. Okay, so lead acid battery consists of a positive electrode. So this is the lithium cell. It consists of a positive electrode made up of lead dioxide, a negative electrode made up of pure lead, and an electrolyte with sulfuric acid. And lithium ion battery consists of positive electrode, metal oxide, that is the lithium cobalt oxide, and a negative electrode made up of graphite intercalated with lithium, and electrolyte, that is lithium salt in the organic solvent. So these are the electrodes and electrolytes of lead acid battery and lithium ion battery. Lead acid battery, and this is lithium ion battery. So if you see here, this is the lithium cobalt oxide and this is the graphite with lithium. These yellow ones are the lithium. This works only like by shuffling the lithium from the anode to cathode and cathode to anode through a separator. And the role of this separator, like lithium ions are very important here. And the electrolyte used is lithium salt in organic solvent. Next, copper deposits on iron nail immersed in copper sulfate solution. So we have a copper sulfate solution in a beaker, for example. Whenever we keep a iron nail, then copper gets deposited. Why this is really happening? Because copper is reactive, so therefore it is converting into copper, CuFe, and then it is depositing on the copper on the iron. So the iron that is coming out is becoming iron sulfate. Therefore, the blue color solution is becoming pale green because of formation of this iron sulfate. So the blue one is because of copper sulfate. So these copper ions are replaced by iron. So therefore it is becoming iron sulfate or ferrous sulfate. So therefore the solution turns pale green and the nail is coated with copper and therefore it is becoming brownish in color. So whenever a nail dipped in copper sulfate solution, iron can displace the copper from its solution. So the iron nail gets coated with brown layer of copper and the color of the copper sulfate turns pale green. So this is how there is a reaction taking place between the iron nail and the copper sulfate solution in the beaker. So next one is, can we store copper sulfate in zinc vessel or silver vessel? Justify. So if we tell zinc vessel, for example, vessel will be in the metallic form. So now we are taking a rod and dipping in the copper sulfate. So then what happens? Because zinc is reactive, so it forms Zn2 plus ions. So therefore it will be degrading. So copper is less reactive than zinc. So zinc will replace these copper ions that are present in the solution. So whenever copper sulfate is kept in the zinc pot, for example, if this is the pot, zinc pot, and this is the copper sulfate, so this zinc will replace the copper sulfate and forms zinc sulfate. Then what happens? This vessel will break. Because it is eaten away or the zinc is removed. Here the zinc sulfate forms and this will break down. So that is why we should not store copper sulfate in zinc vessel. Similarly happens with the silver also. So copper is replaced by zinc in the copper sulfate solution. So copper sulfate solution cannot be stored in a zinc pot. Okay. Next one is, why does a steel pipe in a large copper tank corrode and cause rapid destruction? Rapid destruction is happening in a further steel rod that is kept in the copper tank. So if you see, the steel pipe is nothing but made up of iron. So iron is anodic in nature with respect to copper. So whenever a steel pipe is fitted in the copper tank, it is exposed to atmosphere and the galvanic or the electrochemical corrosion takes place because of forming the anodic and cathodic regions. Anodic and cathodic regions. So therefore the galvanic corrosion occurs, which is very rapid, and that is how the destruction takes place for the iron or the steel rod. Next, calculate the EMF of voltaic cell if the iron Fe2 plus and copper 2 plus to copper. So if we see, the Fe is converting to Fe2 plus and there is a change in state, and this is the salt bridge, and copper 2 plus ion is converting to copper, that is deposit. So this is in the aqueous solution it is forming. So this copper 2 plus ions is converting to copper. Given the potentials, like for copper, it is, this is iron and this is copper. Okay, so for iron Fe it is minus 0.44 volt, and for copper it is plus 0.34 volt. Now we have to decide, like we will be applying a formula E cell is equal to E cathode minus E anode. Now we have to decide whether which one is cathode and which one is anode. What is happening here? Increase in the oxidation state, so this is the anode. Oxidation is taking place, so anode. So this is reduction is happening, so cathode. So now the copper is cathode. So what is the value for copper? It is plus 0.34 minus 0.44 volt. Okay, so then it will be plus 0.78 volt. So the same thing is given here, like iron is converting to Fe2 plus ions and it is minus 0.44 volt, and whenever there is increase in the oxidation state, oxidation is taking place, so this is anode. Here reduction is occurring, and this is cathode. So this is how we have to decide the anode and cathode, and then only apply in the formula. So here we are also using the salt bridge. This double slash indicates salt bridge. So therefore the cell works, and the reaction is spontaneous. Why is it spontaneous? Because the E cell is positive. So therefore the reaction is spontaneous. Next one, galvanized container is not used for storage of food products, but tin coated container is used. Comment on this statement. So galvanization is nothing but we are coating a metal on another metal. So generally we coat zinc metal on iron. So what happens? So whenever we are coating zinc metal on iron, what happens? Zinc is highly reactive. Why? Because if you see zinc, it is minus 0.76. So it is reactive. So it will be reacting with the atmosphere that is present in the food. So whenever food is stored with coating with zinc, it will react with zinc. It will corrode completely and dissolve, and then it will form toxic compounds, because it is ultimately reacting with the food material that is present, and these toxic compounds are unhealthy to the human consumption. That is why we avoid this zinc metal coating on the iron. For example, if it is tin on iron, what happens? Tin is less reactive. Why is it less reactive? Because it is present below the series, in the electrochemical series. It is less reactive compared to zinc. So therefore, whenever tin is used as a coating for these containers, then it does not react, no reaction, so no effect on the food products, and we can use it happily for our consumption. So therefore, galvanized containers cannot be used for storing acidic foodstuffs such as because zinc reacts with the food acid forming poisonous compounds. And tin coated containers or utensils can be used for storing any foodstuff, as tin is non-toxic and protects the metal from corrosion. Because it is less reactive and non-toxic, it can be used. However, zinc cannot be used for coating on the iron. Next, iron does not rust if zinc coating is broken in the galvanized iron pipe, but rusting occurs much faster if tin is coating over the iron broken. So if it means we are having iron here, we are also having iron. So for example, we are coating zinc here and it is broken at some place. So it is broken at some place. And we also have tin here and broken at some place. Broken here. So whenever there is something like that, it is like a defective iron rod or the iron pipe. So this defective iron pipe, what happens is whenever there is zinc, it is highly reactive. Zinc is broken, but rusting occurs much with tin. With tin, it is happening more. So whenever it is reacting with zinc, zinc is sacrificing here because highly reactive. It is highly reactive, so it will sacrifice. It will sacrifice. It will undergo the corrosion completely. However, this is less reactive. Tin is less reactive. So it will allow into the iron. Therefore, with tin, it will be rusting more when compared to zinc. If you see the zinc, it is highly reactive with the potentials also, and tin it is low reactive. So the zinc is more reactive than iron. So this means that if a crack appears on the surface of iron coated with zinc, then zinc will take part in the redox reaction. This zinc will corrode completely, take part in the corrosion reaction that will completely corrode, protecting the iron. In other words, zinc can be corroded in surface to iron, but it is not the same because tin is less reactive compared to iron. So that is why corrosion occurs faster when it is tin is coated. What is galvanic cell? Explain the construction of galvanic cell with electrode reactions. So what is the galvanic cell? We have zinc cell, half cell, and copper half cell. So here in the galvanic cell is nothing but the electrochemical cell wherein spontaneous reactions takes place. Spontaneous redox reactions takes place. It is the galvanic cell is an electrochemical cell where spontaneous redox reaction takes place between two half cells. So here there is a zinc sulfate with zinc rod and copper sulfate with copper rod dipped, and this is connected with a salt bridge. So whenever we are connecting to an ammeter, there is some potential shown because there is redox reaction taking place. So there is no need to apply any other energy. So the spontaneous reaction is taking place. That is why it is a positive voltage it is showing. So the anode reaction here, it is highly reactive. Zinc is highly reactive. So therefore, what does it do? It will give off the zinc 2 plus ions from the rod that is present. So the zinc 2 plus ions will keep on coming out and 2 electrons are coming out. So these electrons travel through the circuit and these 2 electrons are accepted by the copper 2 plus ions that are present in the copper sulfate solution. So that will form copper deposit. This copper will be deposited on the copper rod. So this is how oxidation is taking place. So this is anode and reduction is taking place. This is cathode. So the overall reaction is we are cancelling these 2 electrons. So zinc plus copper 2 plus ions will zinc 2 plus ions and copper. This is how the reactions will take place and keep on generating the current or electricity. So whenever we are connecting along with salt bridge, then only the cell will continue working. Next, explain the construction and working of lead acid battery. Write the discharging, charging reactions and the limitations of lead acid battery. So lead acid battery contains lead and acid, sulfuric acid. So we have lead plate, anode. So this is lead plate, anode and cathode. So at anode, what happens? Oxidation takes place. So this will give rise to Pb2 plus 2 electrons. Same thing is given here. So the lead rod that is present, or the plate that is present, will give off lead 2 plus ions and 2 electrons. And the sulfate ions are coming from the electrolyte that is present here due to the sulfuric acid. So these 2 plus ions will accept the sulfate ions and form lead sulfate. So precipitate. So that will deposit on the electrodes. So this is the overall reaction. Lead plus sulfate gives rise to lead sulfate plus 2 electrons. And at cathode, what happens? This is the cathode reaction. So from 0 state, it is going to plus 2 state. So oxidation is taking place at anode. And here PbO2 is the other plate that is present. So lead dioxide plate that is present. So here it is plus 4 state. The lead is plus 4 state. It is converting to plus 2 state. So reduction is happening in the oxidation state. So therefore cathode. So there's lead dioxide plus H plus ions from this electrolyte will be taken up by the lead ions, lead dioxide, and give rise to lead 2 plus or Pb2 plus and water molecule. And these 2 plus ions are not stable, so they will combine with the sulfate ions that are present in the sulfuric acid and form lead sulfate. Again, precipitation. So the overall reaction is lead dioxide plus 4H plus ions and 2 electrons gives rise to, and the sulfate ions, lead PbSO4 and 2H2O. So this is the anode and cathode reactions that will happen in the lead acid battery. So without any apply of energy, there are reactions taking place. So these electrons flow through the circuit and helps in generating electricity. So that is the discharging reactions. So these are the discharging reactions. Discharging reactions happen due to spontaneous redox reactions. So charging, so whenever we are charging, what happens? We are connecting to a battery. These are discharging. We are connecting to a battery here and supplying energy. So now what happens is, these lead 2 plus ions that are present already will consume electrons that are coming from the battery. So electrons are coming from the battery, so that lead 2 plus ions will consume these electrons. So where are the lead 2 plus ions coming from? Lead sulfate. This lead sulfate will dissociate to lead 2 plus ions, so SO4 minus 2. So these 2 plus ions will consume and convert back to lead plus 2 electrons. So that will convert back to lead. That is how the electrode is regenerated back upon charging. And at cathode also happens the same. The lead sulfate reacts with water, because if you remember, during charging of battery, the mechanic will put on water. So it reacts with the water and gives off electrons and forms lead dioxide. So this lead sulfate with reaction with water forms lead dioxide and 3H plus ions and HSO4 minus and 2 electrons. So overall reaction is, we are giving some energy to these products that are formed, like lead sulfate that is deposited in both the electrodes. So upon applying energy and water, they convert back to lead and lead dioxide in the plates. So that is how upon charging it will go back to their original state and helps in usage again. So what are the limitations or the cons? Very heavy batteries tend to be very large bricks, and because energy density is low. So because energy density is very low, we require more and more cells or the battery cells to combine together to form a battery. That is why more and more plates are kept, so it becomes heavy obviously. So this is the only limitation that we have for the lead acid battery, and also maintenance is also an important limitation. Next, explain the rusting iron with the help of electrochemical theory of corrosion. So it is given like electrochemical theory of corrosion, we have to explain the iron rusting. So in iron, what happens? We have iron, so that will go to plus 2 state. So how does it happen? Because of moisture presence or any other atmosphere that is present around that iron. So it will oxidize to Fe2 plus ions, give off to electrons. So that becomes anode. So this area will become anodic in nature. So the hydrogen ions that are already present in the water or the moisture are formed due to acidic environment, and the following reaction will occur in the absence of air. So in the absence of air, if it is there, then it forms hydrogen. So hydrogen will be evolving. So these two electrons that are present, that are coming out from the anode reaction, are taken up by the 2H plus ions and forms hydrogen. So hydrogen is evolving from these anode and cathode reactions. So the overall reaction will be iron and 2H plus ions giving rise to Fe2 plus ions and hydrogen. So this is how the reaction will take place, and this iron ferrous ion is further, it is not stable, so therefore it is not stable in this state. So further corrosion will occur, because of this iron, and the oxygen or the water molecule present in the moisture will help in rusting and form rust like ferrous oxide, so ferric oxide, and therefore helps in rusting or corrodes. Further corrosion takes place, further reaction occurs. So this is how there is anodic and cathode regions that are forming, and therefore helping in the corrosion or the rusting of that iron. Therefore, it is causing the FeO3 compounds. So that is the rusting of iron with the help of electrochemical theory. Whenever they are giving electrochemical theory, anode cathode regions will be forming. So that is a simple thing we have to remember, like electrochemical theory or the galvanic theory is similar, and anodic cathodic regions form depending on the material that is present. Next, what is cathodic protection? Explain the sacrificial anodic protection method of controlling corrosion and its applications. Cathodic protection is like the metal that is we need to the metal which we need to protect is made cathodic, so that it will not react with the atmosphere or the moisture, so therefore it will avoid corroding. So the method of protecting the metals and alloys from corrosion, making them completely cathode. So what do we have to do? For example, this is iron. The base material used for the ships or any other is iron. So iron is always goes for the reaction, because it will oxidize to Fe plus 2 ions. So to avoid this, there should be some anode, so that this iron becomes a cathode. There should be another anode, so that this becomes cathode. So for that we are using zinc anode, that will become sacrificial anode method. So here, metal to be protected from corrosion connected to more anodic metal. So more anodic metal here is like magnesium, aluminium or zinc, and their alloys. So what happens? They will be reacting. So if you see the ships, there is some zinc kept beneath, so that will be in contact with the water, and that will corrode and sacrifice its metal, protecting the base metal of that ship. So this is how the steel in the ship is protected. The ship hull, which is made up of steel, is connected to a sacrificial anode blocks like zinc blocks, which undergoes corrosion, leaving the base metal protected. So this is how the sacrificial anodic method works in protecting the base metal from corrosion. So next, explain electroplating or define electroplating. Explain the process of electroplating of copper. So copper, we have electroplating of copper here. So electroplating is nothing but coating a metal with a thin layer of another metal by electrolysis process to improve the corrosion resistance, metal's corrosion resistance. Whenever a metal is coated with another metal, it is protected. So therefore, we are coating it using electroplating. Electroplating is nothing but electrolysis. So one of the metal will be helping in coating the other base metal. Electroplating is also known as electrodeposition and electroplated coating. For example, if you see, if we want to deposit copper deposition, then we have to use copper anode. Here the positive is anode, so this is cathode. For example, here the spoon needs to be coated, or the iron object need to be coated with the copper. So this iron object is cathode now. So at cathode, what happens in electrolysis? Cations will go to the cathode. In electrolysis, anode anions and cathode cations. Separation takes place. So we want to coat cations here, that is the copper 2 plus cations. So the copper, this is present, the copper will oxidize to copper 2 plus ions, and this copper 2 plus ions will deposit on this iron spoon. So that is how the coating will be copper coating on this iron spoon. The metal that is dipped will only be coated, not the metal that is outside this bath. So whenever we have to use electroplating, the first and foremost thing is it should be conductive in nature. The metal which we want to coat should be conductive. That is the only specific that we have for this electroplating technique. If you want to deposit on a cloth, we cannot do because it is not conducting. A wood, we cannot do because it is not conducting. Iron or any other metallic can be coated with this technique because they are conducting in nature. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.